All right, so thanks for joining me. I know you're pumped to learn about the different scenarios or situations working with special right triangles. There are two special right triangles that we have in geometry. They are classified by their angle measurements. The first one that we're going to talk about is the 45-45-90 triangle, and the second one we're going to talk about is the 30-60-90. So what I'm going to go over are just each of the cases that you could have when you're working with these triangles and trying to solve for a missing side. For example, for case number 1 here, it says, given the hypotenuse, divide by root 2 for the legs. So I have two triangles. They're both the 45-45-90. And I'm starting with the hypotenuse. So the math, what you're going to do to get the short legs is just divide by root 2. So in this first example here, I have 8 root 2 divided by root 2. Now this is a super easy case because they just cancel out. Both of my legs are 8. So that's awesome when it's a really easy problem like that, but sometimes the algebra will be a little bit harder. The math will be the same, just more difficult algebra. So for my next one, 16 is my hypotenuse. I'm still going to divide by root 2, but I can't... I'm stuck there. That's all I can do for geometry. That wasn't a great sentence. I just mean, we're dividing by root 2 to get the legs, but you can't leave your answer like that because you cannot have a radical in your denominator. So now you have to insert, you have to use the algebra that we did in class about a week ago to change your answer. So I'm just going to multiply by root 2 over root 2. That's just a form of 1, so I'm not changing the value of what I have. Sorry, I'm slanted here. So that's going to give me 16 root 2 on the top over the square root of 4. And this simplifies to 16 root 2 over 2. And 16 divided by 2 is 8, so 8 root 2 is our final answer here. Now just a few things to point out. When you're multiplying a whole number by a number with a radical, you can't combine them. That doesn't become the square root of 32. It just stays 16 root 2. These are both radicals, so I can multiply them. And then, of course, the reason why we multiplied by this was to get our whole number, cancel out the radical. So there we go. There's case number 1. All right, moving on to case number 2. Given the legs, multiply by root 2 for the hypotenuse. So your only other option here for the 45-45-90 triangle is that you start with the leg. So if my leg is 7, that means the other leg is 7, and 7 root 2 is our hypotenuse. Again, a very easy example, requires very little algebra, and you're done. Okay, now for this one, my leg is root 3. So I have square root of 3 times root 2. Now, what I just said over here, since these are both radicals, I can combine them, and I get the square root of 6. And that's your final answer. Now, if this was a bigger number, maybe a 12 or 20 or something, and you could simplify it using the factor tree, you would. But I can't because it's just a 6. So we're done. And this is also root 3. So those are your only options for the 45-45-90 triangle. You're either multiplying by root 2 or you're dividing by root 2. Now, for the 30-60-90. 3 different cases because these sides are all different. So my first case here says given the short leg, multiply by 2 for the hypotenuse, and multiply by root 3 for the long leg. So my first triangle here, I know they're not quite drawn to scale, by the way, sorry about that. My short leg is 6. I'm going to double that for the hypotenuse. I'm just going to multiply by root 3 for the long leg. Oh, that was beautiful. So easy. Just a cinch. But now we'll just make the algebra a little bit harder. So for my second triangle here, I have root 3 for the short leg. When I double that and multiply by 2, that just becomes 2 root 3. I can't combine them because one has a radical and one doesn't. Now when I multiply by root 3 for the long leg, I have root 3 times root 3. And they are both radicals, so that becomes the square root of 9, which just equals 3. There it is. Okay, so you always want to simplify your answer if possible. Okay, don't be messy and leave it as square root of 9. That equals 3. I like that answer better. All right, so that's case number 1. Now, case number 3, I guess, technically. For case number 4, if we're starting with the hypotenuse. Now, for this triangle, This short leg is like the connector of the two longer sides, you could say. So when I have the hypotenuse, I can't go directly to the long leg. Like, I have to solve for the short leg first, and then use the short leg to get the long leg. So, given the hypotenuse, divide by 2 for the short leg. Alright, well, 10 divided by 2 is 5. Boom. Now, I didn't write this down, and you can if you want to, but once we have the short leg, it's just like refer back to case number 3 to finish the problem. Given the short leg, multiply by root 3 for the long leg, so this would be 5 root 3. Okay, but if you're like, I don't know if I'm going to remember that, well, then just pause the video and write it down. Okay, another easy one, right? When it matches the pattern so nicely, it's very easy. But this one, oh my gosh, 12 root 5, that is ugly. Well, it's fine. The math is the same. We're going to divide this by 2 for the short leg. So when I have 12 root 5 divided by 2, that's just going to cancel out and become 6 root 5. Okay, so that's my short leg. Now I'm taking my short leg, multiplying by root 3 to get my long leg. So what do I combine here? The two that are the same. 6 root 15. That's my long leg. Okay? Again, if you could simplify this at all, you would, but since it's just 5 times 3, you don't have it a pair, it just stays 6 root 15. Okay? Are you tired of radicals yet? I hope not. Alright, last case. Given the long leg, divide by root 3 for the short leg. Okay, so, come to my triangle. 8 root 3 is what I have. That's my long leg. When I'm dividing by root 3, oh, look at that. They just cancel out. So nice. And now once I have the short leg, again, this is just refer back to case number 1. Sorry, case number 3. I keep doing that. Given the short leg, multiply by 2 for the hypotenuse. That's just 16. Okay, beautiful. These are all examples of like pretty easy problems, right? It doesn't get any easier than that. And that's very easy. But you have to also be able to do some harder algebra. So here I have 12 for my long leg, and I want to divide by root 3. Well, that's just gross. Okay, again, that would be our answer, but we cannot leave it like that because there's a radical in the denominator. So we are going to rationalize the denominator. Doesn't that sound fancy? You should feel fancy. Right, this is a form of 1, so it's legal. So on the top we get 12 root 3. On the bottom equals square root of 9, which equals 3. Right, just make that jump there. Now 12 divided by 3 is 4, so 4 root 3 is our answer for the short leg. Okay, again, we're going to take this times 2 for the hypotenuse, which will just be 8 root 3. So there you go, ladies and gents. There's all your possible cases for the special right triangles. All I can say is just practice, practice, and practice. And then before you know it, you'll just be doing this in your sleep and you won't even have to think about it. Alright, thanks for watching. Bye.